Okay, folks, welcome to Lecture 8. In this lecture, we'll be taking a look at percentage error and then absolute and relative percentage difference. So percentage error, often called percent error, especially in American texts. So the purpose of calculating the percentage error is to analyze how close a measured value is to an actual value. I often call the actual value the true value in this lecture, so just be aware actual and true are interchangeable. So mostly, guys, you would always express the percentage error as a positive number. So regardless of whether your answer was positive or negative, you would always just describe an error as there was a 5% percentage error in this calculation. And people then kind of would intuitively know it could be positive or negative. But in some cases, you would specify the sign, particularly in a case where values were continually coming under the true value or above the true value. It's very important in that case to point out then the nature of the sign. So generally, you don't keep a sign. In some cases, you do. So the formula is simply the difference. So this difference, guys, is the difference between the actual, I'll just call it the true value because that's what I have it down below, the true value minus your measured value. So it might be in an experiment, it might be an error value, something you recorded incorrectly, but you should always know what the true value is, and usually the wording of the question will define that. So here's a scenario. 3.20 is incorrectly recorded as 3.02 in an experiment. So here's our true value, guys. Again, always identify that first. What's the true value? So determine the percentage error. So we need to find the difference first of all. So here's our true value. Here's our measured value, or our incorrect value. And we want to get the difference between the two of them. So the difference is simply 3.20 minus 3.02, and the difference is 0.18. So the true value then, as I said, is this one. So now the formula looks like this. Now in the next line, guys, I'm simply going to multiply. Remember, the 100 can be written as a fraction. I'm going to multiply the top by 100 and the bottom by 1. And that's what happens here. The decimal point has moved 2 places on the top. Now I can't divide by a decimal, so I multiply the bottom by 10 and I multiply the top by 10, sorry. So really I'm just multiplying by 1. And this gives me the equivalent fraction. And then, guys, when I work that out, I get 5.625. I'm going to try and kind of speed through rather than me doing these out in full, guys. We can presume I'm just doing them by long division, as I know you will be as well. He says, hopefully. So that's our answer there, guys. Oh, finally it says determine the percentage error to 1 decimal place. So here's our 1 decimal place. We look at the next value. So to 1 decimal place, that's our correct answer there. 5.6%. So usually percentage error 1 decimal place is adequate, but you need to have at least 2 decimal places in order to define that decimal place correctly. I hope that made sense. So here's another experimental error. An error, guys, is just, it's not you've done anything wrong. It's not a mistake. It's just a part of measurement. There's nearly always error associated with measurement. It's the nature of the beast. Like, measurement always has error. It depends on the accuracy of your instruments primarily. So when we say error in terms of science, we're talking about kind of a measurement error. Sometimes it is a mistake, but often it's just simply in terms of the limitations of our instrumentation. So in this case, it's kind of a mistake. We're just looking at students' results. So student recorded a value for the boiling point of bromine as this, and the actual value is this. So it's not like the student has made a huge mistake. It's just simply their instruments probably aren't that accurate. So the result isn't going to be true to what the actual value should be. So first thing we need to do is get the difference between the two results. And then, guys, define what the true value is. That's always very important. Now we can write 4.5 divided by the true value multiplied by 100. That's what will give us our percentage error. Now, in this case, guys, first of all, I'm just going to deal with the decimals. So I'm going to multiply the bottom by 10 and multiply the top by 10. Now I simply cancel. Sorry, this is where a little bit of cancelling comes in. So taking a look, guys, these numbers add together to 18. So I know that 9 will divide into the bottom and 9 will divide into the top. 9 will divide in there 5 times. And when you do the maths on this, guys, 9 will divide in there 66 times. Now I multiply the top by 100. Remember, this can be written as a fraction. Again, cancel. We could do the long division now, guys, but we're going to cancel, divide top and bottom by 2. And finally, guys, again, once you do the long division, we end up with a repeating decimal. And finally, percentage error, we should go to 1 decimal place is usually adequate. So to 1 decimal place, my answer is 7.6% error. So that's not too bad, guys, really, in terms of a student experiment. All again depends on the sensitivity of your instruments and how much attention you've been paying to the process. So now, guys, you know the drill. Pause the video and have a go at these problems. So I just bounce them up and let you guys pause and work your way through them. And we'll just continue on then. So now we're going to take a look at kind of where science really starts to take a hold of the course. And we look at absolute and relative error. Very important to understand the difference between these. So we'll just take a look. So we've actually already encountered absolute error and relative error, but I haven't really defined them implicitly. I haven't really said this is this. So we'll just go back and take a look at this example from a couple of slides ago. So we already actually found the absolute error when I got the difference. That, guys, technically is the absolute error. So the absolute error is just simply the difference between the error and the true value. So I kind of just found that, but I didn't describe it implicitly as the absolute error, but that's what it is, that value. When we compare this value to the true value, which we did, that's now called, guys, the relative error. So what I called the percentage error in a more general sense would be called the relative error, because we were comparing our error to another value. So that's what relative means, when you compare one value to another one. This is just simply the difference. Absolute value just means it's generally the simplest version. So now we're just going to take a look. So we'll work the relative error. I've done this already. And we got that answer here, and it's 5.6% to 1 decimal place. So essentially, guys, just to redefine it, absolute error is simply the difference. When we compare that difference to another value, in this case the true value, then guys, it's called a relative error. And it's very important to know the difference between the two. So we just take a look at this example. I kind of decided to do this example first because I had already discussed it in lecture 7. So this, guys, was the when sums go bad. And we just take a look at the IARC's results. So essentially, they carried out what was known as an observational study, guys. An observational study is probably the least scientific way of conducting a study that's acceptable. So this was the first area that the media kind of didn't really understand, like that there was nothing proven, there was no experiments done. Basically, these guys took a look at a lot of data and kind of drew some conclusions without actually testing anybody, without verifying how solid the data really was. The kind of it's called an observational study, and they do have their place, but it should have been defined a lot better before the press releases went out. So essentially, their data showed that 56 out of 1,000 people who eat very little red meat would develop bowel cancer at some point in their lives. Similarly, the same study showed that 66 people out of 1,000 who do eat red meat, a lot of red meat, will develop bowel cancer at some point in their lives. So determine the absolute and relative percentage difference in the likelihood of developing bowel cancer between the two groups. That was this is where now the confusion set in, so to speak. So we'll just take a look at the percentages first of all, guys. Remember, 56 people out of 1,000 who eat very little red meat. So when we convert that into a percentage, we get 5.6%. Now we do the same for the people who eat a lot of red meat. And we see 66 out of 1,000 people, that's 6.6% of people. These again are the likelihood incidence of developing bowel cancer. So the absolute difference, guys, between the two is 1%. I hope you'll agree with that. The relative difference is that 1%, the difference, compared to, guys, what we would call the control group. In this case, it's the people who didn't take the intervention. We're trying to see, does red meat have an impact? So we always compare to the people who didn't take red meat. They're called the control group. I'd say you've met control groups at this stage in your experimental work. So that's these guys here, guys, the people who didn't. Now I'll just get rid of the percentage signs. When we do this, guys, now this is again our relative percentage difference, but because we're comparing a small difference, but we're comparing it to a small value, we'd say we're coming off a low base is how people often describe this. We're coming off a low value already. When you do this sum, guys, what we end up getting is very close to 18%. And this was the figure that the media kind of pounced on. The media suddenly said, oh, people who eat red meat are sometimes they were saying nearly 20% more likely to develop bowel cancer. And you see that when you leave out the bit compared to the people who don't, it's that's where the headlines are made. So the newspaper editors went after this figure, and it just created a very unrealistic picture as to the safety of meat. And secondly, guys, like the observational study was looking at things like the people who ate quite a lot of red meat tended to drink a lot more, they tended to smoke more, they tended to be more sedate. So all these are also factors that would contribute to their likelihood of developing bowel cancer. One thing that was very interesting, it was in the report, but the media didn't report it, was this group actually had tended to have lower cholesterol, which goes against a lot of kind of common thinking. But so there was a lot of stuff in the report, but that's the nature of an observational study. You're trying to kind of pan, it's like kind of panning for gold in a river. You're throwing a lot of data in and trying to see if some nuggets of information drop out. Unfortunately, for the meat industry, there was huge ramifications, as I discussed. So this was the Guardian, and this figure 18% was bandied around every place. Here you can see eating processed meat or red meat was compared to smoking, alcohol, asbestos, and arsenic. Like, it's nowhere, the levels of danger are nowhere near that. So it's just to show, guys, it's very, very important to understand. Are you looking at a relative percentage difference or an absolute percentage difference? Two very different things. So we'll just take a look at a simpler example, because I know that one had quite a bit of data in it. And we just look at two dog food companies. One has 16% content, dog food A, and dog food B has 20% protein content. So the absolute difference is 4%. And when we compare to dog food A, so imagine you're in dog food B and you're kind of looking at your rivals. Well, the difference is 4%. We're comparing to our rivals. So it's very important, guys, to see that this word relative means compared to someone. So it usually has to be defined in the question who you're going to compare to. But we'll come on to that later. So here's our difference. So relative to dog food A, that means compared to dog food A. So dog food A is what goes on the bottom, guys. So we can see now that dog food B, company B, has 25% more protein when compared to dog food A. But very often the marketeers will leave out those last words and they'll just say, oh, we've 25% more protein. That sounds very attractive, compared to 4% more protein. So this is where the confusion kind of comes, guys, and it's where as scientists you have to be quite critical thinking. So company B could say, well, we've 25% more protein than our rivals. And similarly, company A would be justified in saying, well, our dog food has only 4% less protein than our rivals, and both are correct. So it's just very important to understand the nuances of them. And as a scientist, you have to explore. You can't just take one figure and presume it's one or the other. You have to verify it. And that usually means going back, finding the original report and seeing what the raw data was. So this is what science is all about, guys. Honing down to the truth. And both of these are true. I'm not suggesting they aren't. They're both true, but they both have context. So now again, guys, take a wee pause and we just take a look at the alcohol content of two hand sanitizers. So Bactex has 62%, which is actually technically below the recommended level. And CJ Pharma has 70%, which is the recommended level, minimum recommended level. So the question then, determine the absolute percentage difference between the two brands. I think that's fairly straightforward. But now, determine the relative percentage difference in ethyl alcohol comparing CJ Pharma to Batex, guys. So that's what defines what goes on the bottom. Very important, guys, that you define, what am I comparing to? Often you're comparing to the true value, but if we're just comparing two products, as in this case, we have to define it. We look at another example now, guys. And one thing about these as well, guys, just to be clear, is There's more examples on the video and in the notes as well. So try, if you're kind of struggling with these, go and take a look at the notes online, take a look at the other videos. I have different examples worked out in the other videos. I always try and keep the examples different. So we look at one more example. I like this one. You guys. Oh no, this isn't the one I like as much. It's we've a bit to go yet. So here, guys, we're looking at two different types of beer. Craft beer has an alcohol content of 6.2% and Budweiser has an alcohol content of 5%. So again, determine the absolute percentage difference and then determine the relative percentage difference when comparing craft beer to Budweiser. And your answer, guys, will probably be surprising. What looks quite small, again, because we're coming off a low base, we're comparing to a low value, the 1.2 difference is going to have a big impact. And it would also have a big impact, guys, if you were driving or anything like that, on your ability to drive safely or to conduct machinery. So just be very careful, guys. What seems like a small increase in alcohol content can have a significant impact on your sobriety. So again, that's another one for you to try. And now one more. This is the good one. This is the one I like. So here, guys, we're looking at two protein bars. I think you're all familiar with these. On the top, we have a 60-gram bar, and on the bottom, we have a 40-gram bar. Now, these are genuine. The top ones are actually made in Kerry, guys. They're an Irish brand. They seem to be pretty good. I don't eat these things, so I have no idea. I have jiggled the figures a little bit to make the maths better, so don't go by these figures, guys. But they're close enough to the real figures, which I got off their labels online. So now, guys, there's a lot of information going on here. But what I want you to do, remember everything we've learned so far. Determine the absolute percentage difference between the two brands for protein and for sugar. So don't just go, oh, there's 20 protein and there's 10 and the difference is 10. You have to get the percentage. What percentage of this bar is protein? What percentage is sugar? Similarly, what percentage of this bar is protein? What percentage is sugar? Now you're in a position to answer this question. Part C and D now. Comparing NutriGro to All Real. Determine the relative percentage difference of protein and sugar. And finally then, guys, develop a ratio denoting calories per gram and in the order of All Real to NutriGro. Whoops. So again, guys, just give that one a go. The little pause button didn't appear. I meant it to. But you'll kind of see where, what we're doing suddenly has a relevance. It's very hard, guys, at the moment just to compare these figures. Which one of these is better? Because there's a whole lot of data going on. A whole lot of information going on. But once we turn them into percentage differences, now we're kind of comparing like with like. So I'll let you guys bash away with that. If you struggle with it, guys, I'm beginning to push you now. I expect you to start struggling. So show up to the tutorials, have a chat with Kevin, make an appointment with Kevin in the Math Support Centre. We're here to help you, but we're also here to challenge you as well. I think you should expect that. So thanks again, guys, for your patience. We'll finish up there and we'll chat to you again in the next lecture, which will be lecture 9.